In today's video, we will talk about the silicate structure. Silicate mineral groups constitute about 90% of the Earth's crust. They are found in all common rocks except limestone. Silicate structure. The basic unit in all the silicate minerals is the silicon oxygen tetrahedron. The structure is composed of four oxygen atoms with silicon atom at its center, like this. First is the nesosilicate. These minerals are built from isolated silicon oxygen tetrahedron. Then SiO4 tetrahedron is not polymerized and linked to one another by the ionic bonds of the interstitial cation. Atomic packing is dense, which causes the minerals to have high specific gravity and hardness. Crystal habit is equidimensional and it has poor cleavage. Examples are the olivine, zircons, and garnet. There is simple, not polymerized, and isolated silicon oxygen tetrahedron. Next is the sorosilicates. They are characterized by linked pairs of silicon oxygen tetrahedron. Only one oxygen is shared, which gives a ratio of silicon to oxygen 2:7. Examples are the hemimorphites and epidode. Structure is only one oxygen is being shared in case of the sorosilicates, which gives a ratio of silicon to oxygen 2:7. Cyclosilicates. These are also called ring silicates. When each silicon oxygen tetrahedron shares two of its oxygen with the neighboring tetrahedron, they are linked into each other and form rings. They have a ratio of silicon to oxygen 1:3. Example is beryl and tourmaline. The simplest form is Si3O9. See, each silicon is sharing two of its oxygen atoms. Inosilicates, they are also called chain silicates. SiO4 tetrahedron are linked by sharing oxygen to form straight chains of indefinite length. They are also categorized into two types: single chain. In this case, 2 out of 4 oxygens in each SiO4 tetrahedron are shared. Example are the pyroxenes, and the second one is the double chain. Half of the tetrahedra are shares 3 oxygen, while the other half shares 2 oxygen, giving ratio of silicon to oxygen 4:11. Examples are the amphiboles. In case of single chain, the one is the share. No, this is not right one. See, this one is sharing two of its oxygen atom in case of single chain. In case of double chain, see, this silicon is sharing three of its oxygen atoms, and this will be sharing its it is sharing to this silicon and will be sharing to other which is linked nearby. It is sharing two oxygen. First one is this, first second one is this, and this will further link to some silicon and oxygen. Next is the phyllosilicates. They are also called seed silicates. 3 out of 4 oxygen in silicon oxygen tetrahedron are shared with the neighboring tetrahedron. This gives a silicon to oxygen ratio 2:5. They have low specific gravity and have flaky habit. Example are the micas and chlorite, muscovites, biotite. This will be linked to some silicon, this will be linked to some silicon, this will be linked. And so on. It will give a ratio of 2:5, and out of 4 oxygen, 3 oxygens will be shared in the silicon oxygen tetrahedron. Final is the tectosilicates or framework silicates. SiO4 tetrahedron is linked in 3D framework. All the 4 oxygen in each silicon oxygen tetrahedron are shared with the neighboring tetrahedron, giving ratio of silicon to oxygen 1:2. Bond is stable and it has strong framework and electrically neutral. Example are the quartz and feldspars. This will be shared to someone, this will be sent to some silicon, this will be shared to some other silicon, and so on, and it will form a framework like a structure. That's it for today's video. Thank you.